Okay, we're live. We'll start talking about the first question that, as the title says, is about the null space. And for those who have seen or have taken a class in linear algebra, this is not a new concept, but okay, I was sharing the incorrect page. There. Okay. Okay, so let's talk about what the null space is. Have you seen matrices yet, or you know what this is? Yes? Okay, so in this example, I'm defining a matrix, it doesn't matter the numbers, A, or any operator, linear operator, and the null space, or also called kernel, null space, also kernel, is defined as the set of objects, okay, in which, so for example, vectors x in this example are 2, so a times x equals 0. That's the null space, by definition, or just the mathematics of it. But let me think how to say it. Well, basically it's the set of all the elements in the given space that gives you 0, okay? And if you see the homework here, it is written in a different notation, but it's basically the same. Let me first translate this to the notation I just wrote. In the homework, instead of A, they are using x1, x2, and so on as the columns. And this is a matrix X, capital X. And instead of X, they are using alpha in Rn. So this matrix X times alpha equals 0. See? Let me see if I can screenshot this. Okay, I cannot copy paste, but I can put them side by side. Like so. So the only difference with the most common notation is that the matrix A is called X and the vector X is called a vector coefficients alpha. If you don't know why, this is the same as writing alpha 1 x1 plus xn This is because when you do the matrix multiplication here, this one, you basically have this. No, I did put the vectors incorrectly, and the vectors should be transposed. Oh, no, it was correct, sorry. Why? Because you will multiply all this by this. The alpha 1 will be multiplied with this x1, the alpha 2 will be multiplied by x2, and so on until xn and alpha n, basically resulting in this summation. Like that. Okay. So basically what the null space is to find this vector of coefficients for which the linear operator, or in this case the matrix, is equal to 0. 0 vector, not just 0. And how does this translate to the questions? So for example, the question A is to show that n, that is defined as the set of all the alphas, given that x evaluated in alpha is equal to 0, that means that n in this question is the null space of x. You can see it also in the comment here. If you define this matrix that I just defined here, n is the null space of x, the matrix x. So you need to show that n is a subspace of Rn. And the professor even gave you what that means exactly. You need to prove that by choosing some numbers a and b, when you do the linear combination between any vector of coefficients alpha and beta with these two numbers, that also is in n. Have you tried solving this or doing the proof in the question 1a? I can show you how to start if you want. Hello, someone? Okay, so how exactly can you prove that a vector, for example, alpha, is in this set? How do you answer this? Okay, so Carla, that's a good point. This matrix here that I just wrote here, it seems that only has one row, but actually it has the same number of rows as this. And the thing is that each row here is defined by vectors. So in reality this is this vector x1, but the first component then the vector x1, but the second component, and so on, until the last component. Then for the second vector, the same, and first component, right? Component. So it is a matrix, and the matrix is exactly the same as this one, but I just wrote it in a different notation. Okay, let me move this a little bit. Okay, so how can we answer this question? Is this vector coefficients alpha in this set N? We need to remember that the definition of N, this double dot equal means by definition is equal to then this brackets means that is a set of elements. Okay, then you have all the alphas in Rn. Then you have so label alpha in Rn. So this expression is valid, or in this case, no, I already used this color here. X of alpha equals to 0. That is the same as saying, by definition, because you have a definition here, that alpha 1 x1 plus dot 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 alpha n until xn equals 0. So obviously, if you are trying to do a linear combination of this alpha and beta that already are an element of the null space, it's obvious that the first condition here in light blue is satisfied, right? As the first elements, alpha and beta, are already in N, obviously there are also element in Rn, so we don't have a problem with this part in light blue. The only thing we need to check to see if the addition between alpha times A and beta times B is in the null space is this expression here. This is what we need to verify. Everything clear until this point? Or there's any doubts? Clear? Clear? Okay, so basically what we need to do is to define, let's say, gamma equals to A times alpha plus B times beta, and replace this gamma into this expression here. So we need to verify that sorry, gamma 1 x1 plus gamma 2 x2 and so on until the end is equal to 0. So that's what you need to do in that question. I will not do it. You'll have to do it. But it's not very complicated. You need to use the linearity of the summation and you can pretty much conclude this. So this is the exact thing you need to do in that question. For question B, see, what can you say about the collection x1 until xn if the null space is just this? You should have seen this in class. You know what happens to the collection if that is true? No? Anyone has some ideas of what concept of the class can be applied in this question? The vectors x1 to xn are linearly independent. Let's see. That this really don't really remember, but I think it has to do something with a trivial solution. Yes. If this matrix only has a trivial solution when you do the kernel, that means that when you have alpha x1 plus dot 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 alpha xn xn, this is only equal to 0 if all the alphas are equal to 0. And this here is a definition for linear independence. What? Okay, so for the C, question C, let me create another page. Forgot how to create a page. With this. For the question C, what can you say about the collection if n contains at least one non-zero vector? What can you say about the collection? If in the last question the answer was linearly independent, in this is okay. So you can guess the answer of that, right? But what you said in the chat is correct. That's the solution. Okay. Now for the second problem, I didn't put that one here. For the second problem, you can see that you have a lot of points in time. You have time, you have t sub 1, t sub 2, until t sub d, and they are defined with this expression, I minus 1 divided by d, and I, this running index, goes from 1 until d. If you evaluate this in 1, you get that t1 is equal to 0. So this is equal to 0 until when you put I as d, and you get d minus 1 divided by d. That is approximately 1. So basically you're defining a set of points between 0 and 1. You're defining d points, between 0 and 1. What function we saw on the tutorials that can do that? In Python, of course. Yes, we can use range, but a more similar function to this, an array. Yeah, the Null Space. The Null Space function can define a vector of points given a start, an end, and the number of points, that in this case is d. So basically you can use line space to do this, or you can use range, or however you want. Okay, so then you define p sub j of t as a polynomial, t raised to the power of j. And that's basically our vector in this case. Then consider also monomials. For example, we consider the collection of vectors p. Okay. So instead of vectors, we are using a function sampled in those coordinates. In Python, that means that my first vector, p sub 1, is equal to this function, t star star 1, p star star 2, and so on. So t raised to the power of 1, t raised to the power of 2, those are our vectors we are defining. Then show that n, if n, what is n? What's the definition of n? The number of vectors. So this goes until the polynomial n, that is t raised to n. The number of points is d, and the number of polynomials is n. If the number of polynomials n is less than d, the collection of these vectors p0 until pn is linearly independent. To show this, use the fundamental theorem of calculus. A polynomial of the form this can be 0 at most n points unless all the coefficients are equal to 0. I think this is not the fundamental theorem of calculus, it's the fundamental theory or theorem of arithmetic. Arithmetic or No, it's not the fundamental theorem of arithmetic. It's the fundamental theorem of something, but I don't remember what. Okay. Are you still there? Are you alive? Any questions? Are you understanding what I'm saying, or you are still confused? Sorry, what? If you want, you can ask something in Spanish. There's no problem. I will answer in English, but you can answer in Spanish. No? Okay, I'll continue. Okay, so any of you have any idea how to do this? The derivative? I'm not sure if you have seen derivatives. I think it's not the idea of the question. At least I don't think that was the intention. This is the fundamental theorem of algebra. I just remembered. Fundamental theorem of algebra. What it says that a polynomial of degree n has n solutions, basically. And the solution is defined by when the function is equal to 0. So for example, if I have a polynomial, let's say something like this, and this is t, the solutions are this point, and this point. Here I just draw a polynomial that is something like t to the power of 3 or something like that. But these solutions can be complex in the complex plane. None of you have any idea how to start this? Let me see the chat. Maybe we do the derivative of the polynomial. I don't think that's the idea of the question. So basically what the question is saying is try to prove that when this happens, the collection is linearly independent. And how to do it? You need to use this. Okay? So basically, what they are implying is that you do something like A0, P1, is starting from 0. Here I was missing 1. Starts from P0 equals to T raised to the power of 0. So basically what you have is A0 times this vector P0 plus A1 times the vector P1 and so on until Pn. And this is a vector. A summation of vectors is a vector. So basically what I'm saying here, to prove that this is a linearly dependent set, sorry, I forgot this An. I need to prove that this is equal to 0 if and only if all the coefficients A0 until An are equal to 0. And how to do it? By using this fundamental theorem of algebra, because we'll have this function here that it can only be 0 at most n points, right? And the fact that the number of degrees is less than the number of points tell us something. The trivial solution? Yes. So if we are saying that the set or the collection P1 until Pn is linearly independent, means that this is only 0 when all the coefficients are 0. So you need to think a little bit about how to relate this to this. Okay? It's not very far away from the answer, but I can't tell you a solution. But you need to start with this, and then see how you can apply this fundamental theorem of algebra to infer that the vectors are linearly independent. Let d equal to 100 and n equals to 2 using matplotlib. Plot any linear combination of this. You want to indicate the scalars you used. What kind of polynomials do you get by taking linear combinations of P0, P1, P2? As we have already said, the first P0 is constant. The first polynomial is linear. Then the second one, or the third one, depends how you see the numbers, is quadratic. And so on. So, depending on the coefficients that you use, the linear combination of P0, P1, and P2 will be quadratic if all the coefficients are different than 0. But if the coefficient that has P2 is equal to 0, it will be a linear polynomial. And if the last two coefficients are 0, it will be a constant polynomial. So you need to think the space of all the linear combinations between P0, P1, P2, which type of polynomial represents. And then can you generalize that idea for n greater than 2? Okay. Someone has started trying to solve these questions? But any of you have tried to do the problem number 1, for example? The problem number 1 should be easy. With the things we just talked, should be very straightforward. The second one implies using Python. So maybe I can help you a little bit on how to implement this. Do you know how to do, for example, the question B? How to do this linear combination in Python? No? Okay, for example, if we are in Python, here I have Python from NumPy import arrange t equals to arrange I forgot how to use arrange. Let me see. Help. I forgot how to use it. Help. Arrange. No. This. Sorry. Let me see how to use it. Help. In Python. Arrange has double R. Yeah, yeah, but the invalid syntax is not because of arrange. And I don't think it has double R. Okay, so it was like this. Arrange. Okay, there it goes. Arrange is a function. No, it's with one R. The problem was that I wasn't using the help function correctly. So arrange has a start, a stop, and a step. So arrange, by the way, it means array range. With range, the function that we have already seen that has a start, a stop, etc. The only difference is that this arrange function generates an array directly. Okay, so from 0 to 1, let's say 3 points. Let me see what it does. No, it didn't do what I wanted. Null Space. So Null Space 0, 1, 3. Okay. It is this one, but we have a problem here. Because it ends in one, not arrange. I need to define the number of points. Let's say d is equal to 3. Then arrange from 0 to the stop, and the step needs to be this one here. So the step is 1 divided by d. There you go. That's what I wanted. So t is arranged from 0 to 1 with the step 1 divided by d. And with that, we define exactly the vector t sub I for all the i's. So let me change d to 100, because that was the question is telling us, equal to 100. Then t is equal to this, n equals to 2. That means that I need to define a p0 equals to t raised to the power of 0. P1 is t raised to the power of 1. P2 is equal to t raised to the power of 2. And basically, I will have a linear combination of them. Let's call it f is equal to 1 times p0 plus 2 times p1 minus p2. That's a linear combination of them. And now I want to plot the functions from matplotlib pyplot import plot and show plot t comma f. Maybe that works. No. Show. And this is the linear combination. So this is with coefficients 1, 2, and minus 1. But what happens if, for example, we do a 0 here? Instead of minus 1 plus 0 times p2. When we do this, have the polynomial is a straight line with an offset. It's not starting from 0, it's starting from 1. And if instead of a 2 here, we use 0 times p1, we have that is a constant function. So that way you can do this question b. And then you need to think what happens when n is greater than 2. Okay. Let d equals to 4, n equals to 3, define the vector this, cosine, using numpy, find the scalars such that this is equal to this. Okay. Basically, you need to do the Taylor expansion. Can you explain the plot part? Okay, so for the question B, what you need to do is to generate these vectors p0, p1, and p2 that are the polynomials sampled in these t's, this vector of t's. And when you do a linear combination between the first three with coefficients 1, 2, and 0, no, 1, 2, and 4, for example, what I'm doing here with the plot function is that I'm using, to define the x-axis, I'm using the t, and to define the y-axis, I'm using the polynomial or the linear combination f. This semicolon is just used to do two things in the same line instead of using plot and then show. And plot generates the plot but does not show the plot, and show creates the window that generates the plot. If you wanted, for example, to do a more complex plot, you can import also x label, y label, and before show you can do x label equals to t, y label equals to y or whatever, and then show, and you have the t here and the y here, and this is the function. You can also add a grid using the grid function. Grid on, and now you have a grid. So you can play a little bit on how to plot it. So that's what you need to do in B. You need to do something very similar in C, but instead of using d equals to 100 points, you need to just use d equals to 4. To use the cosine function, you need to import it from NumPy. So from NumPy, you can use line space, no, sorry, arrange, and the cosine function, and also pi. I need to, yes, you need to import pi also. Pi being the 3.1415. To complete, you use tab, yes. By using tab, I can autocomplete. X label. Now what it happened here is that the line is too short, so x label. If I do it like this, you can see that I wrote x label, but it just felt short, and the rest of the word went to the second line. Okay, so to define this vector, I need to redefine d. D now is 4. T. Where is T? T. I run it again. Now is 0, 0.25, 0.5, and 0.75. And the vector f is equal to the cosine of 2 pi times t. And then you have the vector f. So f is this. 1, 0, 1, 0. That's it. And you need to find a linear combination with the polynomials until the third degree, so you can represent f. So I'm lacking 1. I need to redefine all the vectors again. P1, You can do this with a for loop, but I'm not doing it just to illustrate it better. 3. So you have these vectors, p0, p0, that is 1, 1, 1, p1, that is 0, 0.5, then you have p2 and p3. And you need to find a linear combination of these, so it's equal to f. Using matplotlib, plot the functions, this and this. So basically what is the linear combination we have already done, but with an additional term, and f. If you do t comma f, you can see that this is basically the function f. To see the individual samples, you can also do this. And you now see the dots. X. You can use X instead of a dot. And if you want, you can also use matplotlib. Here you can also use stem. I think, yeah. So instead of plot, you can use a stem. And it's this. Example 1, 0, -1, 0. And the red line, I think it's the imaginary part. The blue part, sorry, the real part is the blue dots. So can you find a linear combination of the polynomials p0 until p3 that gives you this f? Have you seen how to solve this? Yes? Have you seen how to solve x times, a times x equals to v in class? No? Yes? Yes? No? Okay, it seems that you have it. So to do it, you need to do from NumPy the linear algebra in alg, import, solve, and what it does is to this solve function finds the vector of coefficients x, so the linear combination between the matrix that is represented by all these polynomials give you the right hand side. So I need to do a matrix. I don't remember if you can use cat. From NumPy import concatenate. See. So the matrix A, concatenate. I forgot how to use concatenate. So I ask the Python, and you give concatenate a tuple of vectors and the axis in which you want to concatenate. So that's very easy. A equals to concatenate P0, P1, P2, P3, and the axis is the 1 axis. So let me see. P0 dot shape. Should be correct. Axis 1 is out of bounds for array of dimension 1. Maybe what we need to do is to, when we define T, we need to do a reshape of size D, comma 1, and then define everything. Like that. Then the concatenate function should work. Yes. And I need to define f also. Where is f? Here. So basically, to find the coefficients, I need to do solve a, comma, f, and that's the solution. So I need to multiply the p0 vector by 1, the p1 vector by minus 1.33333, the p2 vector by minus 16, and the p3 vector by 21.333, and so on. And how can you do that? I will save these coefficients as a0 times p0 plus a1 times p1 plus a2 times p2 plus a3 times p3, and I will save this as g. Alright, and now I will plot the functions. I'll just wrote it. I will just write it again. Sorry. T comma f, T comma g. So they are basically the same. Maybe I will change the. So the first one will be a red O, and the second one will be a blue X, like that. So as you can see, the blue is our solution, and the red one is the original vector f, and they are exactly the same. Any questions about this? Reshape. What happens with the reshape? How does it work? Okay, so at first it was the concatenate function was throwing an error saying that the vectors here, p0, p1, until p3, had only one dimension. So I couldn't use the axis equals to 1, because 1 in Python means the second axis. The first axis is 0 and then 1. So it didn't have a 1 axis. To do that, here, let me show you. I'll write it again. If I just use the lim space here, from 0 to something, like that. Sorry, what was there? Float cannot be interpreted as an integer. Oh, sorry. This is 3. Okay. For example, I have this vector t. You can see that t, the shape of t is 3 elements down, but it doesn't have any other elements. It's just those 3 elements. The reshape function, what it does is that I can change the orientation of the vector. I can change a vector to a matrix by using, for example, 3, 1. Now instead of going to the side, it goes down like a proper vector, and the shape by some reason is oh, sorry, I didn't save the vector. T equals to t. Okay, so now the size is 3, 1. So basically you can reshape the vector however you want, and restrain that the new vector needs to have the same number of elements that the previous one. And another example could be from 0 to 1, but with 9 numbers. And you can use the reshape instead of 3, 1, 3, 3. And now T is a matrix. So previously it was the vector like 0, this, and so on, but like a vector, and now I am reshaping it as a matrix. That's how the reshape function works. You need to specify the number of rows and the number of columns you want the new vector. So an array dot reshape, you need to specify the number of rows and columns. If you're not sure how to use a function, you can always ask Python. For example, reshape. Sorry, it will not work. But if I do array.reshape, I'm not quite sure how to ask for a function that is inside the arrays. Let me see. Maybe I need to numpy import reshape. Yeah. Whoops. Like that. And here you can see how to use the function. So this is another function. It's not the same reshape I'm using. This first vector is an array, and then you specify the new shape as a tuple. Here you can see all the arguments and the explanation of each of them. Okay. Okay, so we have 5 minutes left, and for this question, that is the cipher, the question number 3, you need to, first of all, download the code example.py. This one, sorry, example.py. That is basically calling a function blackbox1 and blackbox2. These are not actually functions, are a class from a package called blackbox. And this will not work if you don't have, obviously, the black box package that I did. And to import this, in the same folder, you need to have this empty document. So you can see here, the document doesn't have anything inside, but it's called init.py with this lower, like, minus signs. I'm not sure how they are called, but basically it needs to be called like that. The the name is important, like this, init.py. In the same folder you have your Python documents. You need to create this. If you don't have this, the code will not work. You will not be able to import Blackbox. Okay? So in the same folder, you need to have this, the init.py file. And how the Blackbox works. Let me see if I can put it here. Okay. Okay, so this is the Blackbox document. These are the definitions. And this is the example.py. It's importing Blackbox 1 and Blackbox 2. If you run this, you should see those outputs that are the encrypted vectors of a message. The message here, it's called V, and to encrypt the message with the black box, you need to do black box parentheses dot encrypt and the vector, and that will give you a new vector that is encrypted message. So that's how you use it in Python. And the idea of this question is that you need to find a method to solve the keys. The keys are inside Blackbox, are defined in this question as just vectors. And the easiest way to do it would be interpreting this as a matrix. So for example, in the question number 3, if the keys were a matrix, the key 1, key 2, till the key n, and your message keys is alpha 1, alpha 2, alpha 3 until alpha n. To find the keys by sending messages, the easiest way to do it would be to just send alpha 1 equals to 1, for example, and all the others equal to 0. That will give you 1 times x 1 plus 0, all the zeros. So basically, by sending this message, you are already solving the first key. The problem with doing this for every key is that in the questions, as you can see here, the messages that you are able to send are from 1 until 26, because they are letters. They correspond with letters or of the alphabet. So you don't have a 0th letter. Basically, you need to think a method by sending messages to find the keys. But this message vector cannot have zeros. That implies that this is basically a linear algebra problem. And after doing that, after you manage to find the keys, you can then solve the messages. Because when you have the keys, you basically have a matrix. You can apply the inverse of the matrix and find the message. And after that, you need to use the keys to decipher those two vectors. The solution of C and D are letters. It's a message. So after you find the numbers of the solution, you need to translate them to letters. Okay? We don't have more time. It's already 12:50, so anyone has another question? If not, we'll end the TA right here. Or maybe I'll end the English portion and you can ask me in Spanish.